The last lesson for week 7 is applying everything we've learned about trig functions. So, just like we're still talking about what the inverse is. Subtraction undoes addition, multiplication undoes division. The inverse trig functions undo the trig functions tangent, sine, and cosine. Specifically, inverse trig functions are used to solve the measure of an angle of a right triangle when the ratio of two sides is known. This is the inverse or opposite of determining the ratio from a known angle, right? And we're going to use sine, inverse sine, inverse cosine, and inverse tangent. All right, so we're going to solve for theta in this problem. Notice the same steps that we used many times ago, right? We use these little 5 steps right here. Mark the reference angle. Okay, let's mark the reference angle. Label hypotenuse, opposite, and adjacent. This is my hypotenuse. This is where I'm standing. This is my adjacent because my arm is touching there. And this is my opposite. Circle what I know. I know the hypotenuse and I know the adjacent. So I'm going to set up the equation. So if I do SOHCAHTOA, and I have adjacent and hypotenuse, that's going to be cosine. So let's set up the equation. We know it's cosine, but since we're looking for the angle, it's going to be inverse cosine. And we're going to do, well, I can set this up. So cosine of theta equals adjacent over hypotenuse, which then means you're going to take that 10 over 13 and set it up, and that's going to give you theta. So when we go to our calculator, let's go to the calculator right over here, and let's clear this, and we're going to do inverse cosine of 10 divided by 13, and that gives us 39.715, or if I round it, oh yeah, 715. Okay, so let's go back to our paper. And we got theta equals 39.715 degrees. Right? That's basically, we're just practicing the same stuff. The steps stay the same. When we talk about applications of what we learned, it's because it's a word problem. Everything in the world is a word problem. Okay, when your mom sends you to the store and she says buy this, this, and this, you have to remember those things, those words, and that's all this is saying. Let's look at this problem. The Bungling Brothers Circus is in town, and you are part of the crew that is setting up the enormous tent. The center pole that holds the tent is 70 feet tall. To keep it upright, a support cable needs to be attached to the top of the pole so that the cable forms a 60-degree angle with the ground. We're just going to draw the picture. Here's the center pole. The cable has to come out here. If this is the cable, okay, and then it has to form a 60-degree angle. We know that the pole is 70 feet tall. Well, you're going to put the pole in straight, right? All right. So now, how long is the cable? Well, this is just solving. We just have to go through the steps. Mark my reference angle. This is my hypotenuse. If I'm standing here, hypotenuse and adjacent. Then this side over here becomes the opposite. Let's circle what we have, opposite and hypotenuse. So if we do SOHCAHTOA, okay, notice I always write that. I have opposite and hypotenuse, opposite and hypotenuse. So we're going to do sine of 60 equals opposite over hypotenuse. And we're going to solve that. Let's do 70 equals x times sine of 60, divide both sides by sine of 60. You're going to get x equals, I typed that into my calculator, and I got 80.83. Okay, so the cable is 80.83 feet. Because in a word problem, your answer should be a complete sentence. You probably want to see what I wrote, huh? Okay. How far from the pole should the cable be attached to the ground? Well, let's see. What do we have? We have, let's draw our picture again. we know now that the cable is 80.83. This is 70, this is 60, and now we don't know that one. There's two ways I could do this. There's two ways. So I'm going to just write two ways to solve. Okay. We've been practicing, okay, trig functions. So let's see if this is my hypotenuse. I'm standing here. This is my adjacent. This didn't change. So now what if I wanted adjacent and opposite? Okay, one way is going to be to use the trig ratios. Okay, and in this method, we have adjacent and opposite, SOHCAHTOA. So we're going to use tangent of 60 equals x over 70. And we're going to set up the cross products. You're going to get x equals 70 times tangent of 60. And we go to our calculator. I don't have this one done, so we're going to go together to our calculator. And we're going to do 70 times tangent of 60, and that's 121.24. 121.24. Did I do that right? Tangent, opposite over adjacent. Oh, I have this backwards. This should be opposite over adjacent. Oh, I messed up. Hold on. Let's go back. Tangent is opposite over adjacent. So it's x. So I set up this wrong. So I'm going to get 70 when I do cross products equals x times tangent of 60. How did I know that was wrong? Okay, well, I got an answer 121. I'm saying that how could this distance, which is not the hypotenuse, be larger than the hypotenuse? So that kind of clued it for me that, oh, the hypotenuse is always the longest side, so I can't get something longer. So then I went back and looked at my equation. Sorry about that, but now we're going to do this correctly, and we're going to divide both sides by tangent of 60, and then type that into the calculator, and 70 divided by tangent of 60 is 40.41. All right, and the second way to solve that, I'm going to put it up here. Way 2 is the Pythagorean theorem. Okay, because we can do a squared plus b squared, or a squared plus b squared equals c squared. And in my triangle, let me just draw that triangle again. This is 70, 80.83, and then the unknown. So we can do 70 squared plus x squared equals 80.83 squared. And we get a big mess, but we're going to get, this is 4,900 plus x squared equals, now what's 80.83 squared? Let's see. Clear. We're going to get 80.83 squared. Where's my squared button? Type it this way, to the power of 2. That's 6533. And then we're going to take that and subtract 4,900. And what do we get? Oops. 80.83 to the power of 2 minus 70 to the power of 2 equals, that doesn't seem right. And what's the square root of that? Okay, the square root, I cannot see everything. Oh, here we go. We're going to now go take the square root. We're going to go to the next line. We're going to take the square root of 1633.4889. But look at 40.41, which is exactly what we got when we did it the other way. And honestly, the other way using the trig functions was so much easier. All right, let's go back to our paper. Right, so we ended up getting some big number here. 80.83 squared. We ended up getting x squared was 1633 point something, and then when we took the square root of it, we got 40.41. All right, what did you like better? I like the trig functions. Trig functions is so much nicer than Pythagorean theorem. All right, let me set you up for your homework on the next page so that you can be successful. I will put the answers so you can look at the answers to pages 2, 4, 6 just to see that you're doing it right. Draw and label the situation. Okay, an airplane takes off and climbs at an angle of 11 degrees. So this is 11 degrees. He takes off. If the plane must fly over a 120-foot tower with at least 50 feet of clearance, okay, what is the minimum distance? Well, this is going to be 120 plus 50, or 170 feet, right? Not degrees. And then let's see, where the plane must leave the ground. Draw and label the situation. All right. What is the minimum distance between the point where the plane leaves the ground and the tower? So we're looking for this distance right here. All right. So we're going to label our sides. This is hypotenuse. This is where I'm standing. Hypotenuse, I always touch hypotenuse and adjacent. And then here I have the opposite. So what information do we have? We have opposite and we have adjacent. So SOHCAHTOA. SOHCAHTOA. I have opposite and adjacent. It's this one. So we're going to go tangent of 11 degrees because the degrees always goes with the trig functions, equals opposite 170 over x. Well, there's your setup. Now you're going to solve it. You're going to get your cross products and you're going to tell us what the answer is. So you're going to finish this problem and do these 4 down here at the bottom. That is your homework for this section. Have a great night.